A planet exiled, a decision that divided the scientific world for nearly 2 decades. In 2006, Pluto was officially demoted from its place as the 9th planet of our solar system. But why Pluto? Why strip a celestial body that had been celebrated for generations? In just a few hours of heated debate. Was this a scientific milestone or a monumental mistake? Join us as we reopen the cosmic file, unravel the unsolved mysteries, and ask the question, did Pluto really deserve to be erased? In the late 19th century, scientists Urbain Le Verrier and Percival Lowell noticed slight irregularities in Neptune's orbit. They believed an unseen object was tugging from the dark. Lowell named it Planet X. He spent over a decade calculating its location, but passed away in 1916, never finding it. Years later, at the same observatory, a young man named Clyde Tombaugh picked up where Lowell left off. Using a 13-inch telescope, he photographed the night sky and made a discovery that changed space history. Tombaugh used a special device, a blink comparator, to examine starfield photos taken days apart. And there it was. A tiny, moving dot among fixed stars. Undeniable proof of a new celestial body. On March 13th, 1930, the discovery was made official. The world welcomed Pluto. Named by Venetia Burney, an 11-year-old girl from England, inspired by the god of the underworld. A fitting name for a frozen world drifting nearly 6 billion kilometers from the sun. It wasn't just a scientific milestone. It was a cosmic whisper from the edge of our solar system, sparking imaginations across the globe. After its astonishing discovery, Pluto was quickly proposed as the 9th planet in the solar system. But in the 1930s, astronomy was still in its infancy. Through even the most powerful telescopes, Pluto appeared as a faint, flickering dot. Its size and mass were unknown, leading to wildly inaccurate estimates. Some believed it was larger than Earth, based on presumed gravitational effects on Neptune's orbit. But as technology improved, advanced telescopes and spectroscopy revealed the truth. Pluto was far smaller than expected. Still, on May 1st, 1930, Pluto was officially recognized as the 9th planet, expanding our solar family to 9 members. Pluto's discovery was historic, not only because it pushed the boundary of the known universe, but also because it marked the first time an American astronomer discovered a new planet, a moment of national pride. So what makes this distant world so unique? Pluto measures about 2,377 kilometers in diameter. Just 18% the size of Earth, and even smaller than our moon. For nearly 8 decades, it was considered the smallest planet in the solar system. Its mass is only 0.002 times that of Earth. Little to generate strong internal pressure. Its shape is nearly spherical, but not perfect. Weak gravity leaves subtle distortions on its surface. Still, these numbers remain imprecise, as Pluto reflects so little light, making it difficult to study from Earth. It wasn't until the New Horizons spacecraft flew by in 2015 that we finally obtained accurate data, revealing a startling truth. Pluto is so small, it's hard to believe it was ever considered a peer to the major planets. Its tiny size is striking, but it's Pluto's icy composition and its position on the edge of the Kuiper Belt that truly define the unique nature of this distant world. Beyond its humble dimensions, Pluto's surface turned out to be a profound surprise, deepening the mysteries that once cloaked it. Before the New Horizons mission, scientists imagined Pluto as a frozen, featureless sphere. locked in time by its vast distance from the Sun. But when the first images arrived on July 14th, 2015, an entirely different picture began to emerge. If Pluto's quiet, yet extraordinary journey sparked your curiosity, leave a like, share this story, drop your thoughts in the comments, and subscribe to our channel for more cosmic mysteries waiting to be uncovered at the edge of the universe. Pluto's surface is a frozen tapestry of mystery and motion. Towering nitrogen ice mountains like Hillary Montes rise from a hardened crust, surrounded by vast, smooth plains stretching for hundreds of kilometers, interlaced with ancient, cratered regions. This striking contrast suggests Pluto isn't silent, but may still breathe through subtle geological shifts. Smooth plains like Sputnik Planitia resemble glacial flows, nitrogen ice creeping forward like a sleeping breath. The icy peaks may be silent voices from beneath, pushing upward in defiance. But at 5.9 billion kilometers from the Sun, where light and heat barely reach, where does the energy come from? Scientists believe radioactive decay deep within Pluto's rocky core might be the hidden source of heat. But the truth remains an unsolved riddle. Leaving the icy surface behind, we look up, toward a fragile veil of atmosphere. Pluto's thin air, made mostly of nitrogen, with whispers of methane and carbon monoxide. When Pluto drifts far, 7.4 billion kilometers from the Sun, surface temperatures plunge to minus 230 degrees Celsius, freezing gases into a frost that coats the planet. But as it draws nearer, just 4.4 billion kilometers away, temperatures rise to a frigid minus 220 degrees Celsius, enough to let frozen nitrogen and methane sublimate, forming a hazy atmosphere that stretches 100 kilometers high. Delicate, yet wondrous. Strangely, this fragile shell of air is far from stable. Pluto's gravity, just 1/15 that of Earth, is too weak to hold its atmosphere tightly, allowing gas molecules to drift into space at hundreds of kilometers per hour. And yet, miraculously, the atmosphere persists over millions of years, perhaps constantly replenished by icy surface layers, or by unseen forces deep within. Surrounding the planet, a ghostly haze lingers, born from methane molecules shattered by ultraviolet sunlight. This mist doesn't just cloak Pluto in mystery. It also bends the light that reaches us, making Pluto one of the most elusive celestial bodies to observe from Earth. But perhaps the most breathtaking sight is the frozen heart itself. Tombaugh Regio, a vast, heart-shaped region stretching nearly 1,000 kilometers, pulsing silently in the darkness of the Kuiper Belt. Not only is it the most recognizable feature in every New Horizons image, it's a chilling symbol of all that we have yet to understand about this distant world. To the west of Pluto's heart lies Sputnik Planitia, a bright icy plain made of frozen nitrogen, methane, and carbon monoxide. Scientists believe it was once a massive impact crater, now filled with atmospheric ice. Beneath the surface may lie a soft, slow-moving layer, like a glacier, giving the terrain its smooth appearance. Another theory points to convection, where fresh ice rises, pushing older ice aside, forming crisp surface lines. But what powers this movement on such a distant, frozen world? Possibly slow radioactive decay from Pluto's rocky core, uranium and thorium, generates just enough heat to keep its icy heart beating. Though its exact scale and mechanisms remain unclear, Pluto's icy heart, Tombaugh Regio, still stands as a symbol of quiet complexity. From that frozen land, we now trace its unusual orbit. Unlike planets that follow neat, circular paths along the ecliptic, Pluto drifts on a tilted course, 17 degrees off-plane. Its distance from the Sun ranges from 4.4 to 7.4 billion kilometers. And for 20 years in each 248-year cycle, it even slips inside Neptune's orbit. A small body, yet bold enough to defy boundaries. What do you think? Has Pluto ever truly followed the rules of our solar system? There was a strange moment in time when Pluto drifted inside Neptune's orbit. From 1979 to 1999, it temporarily became the 8th planet from the Sun. A quiet reversal that stirred doubts among scientists. Was Pluto truly born within our solar system? Or is it a captured wanderer from the Kuiper Belt? A cosmic outsider with its own untold tale? This unusual orbit doesn't just disrupt planetary order. It also drives Pluto's atmosphere and surface through freezing and sublimation cycles, responding to its shifting distance from the Sun. And when we speak of Pluto, we can't ignore its silent companions. Most notably Charon, the largest moon, discovered in 1978. With a diameter of over 1,200 kilometers, nearly half that of Pluto itself. A moon, or perhaps a soulmate. They orbit together like two inseparable shadows. What do you think makes this relationship so unique? If Pluto's quiet yet extraordinary journey sparked your curiosity, leave a like, share this story, drop your thoughts in the comments, and subscribe to our channel for more cosmic mysteries waiting to be uncovered at the edge of the universe. Pluto and Charon form a rare binary system. Instead of one orbiting the other, both revolve around a shared center of gravity 17,000 kilometers above Pluto's surface, like a silent cosmic dance at the edge of the solar system. Charon, the largest moon, has an icy surface marked by massive rifts and craters like Vulcan Planum, hinting at a turbulent, independent geological history. Pluto also hosts 4 smaller moons, Nix, Hydra, Kerberos, and Styx, spotted by Hubble. With sizes from 10 to 50 kilometers and tilted, eccentric orbits, they suggest a chaotic origin, possibly from a colossal ancient impact that birthed Charon and scattered debris into space. Much like how Earth's moon may have formed, Pluto's interactions with its moons enrich its story and offer clues about the origin and evolution of this distant system. From its nearby companions, we now turn to a cosmic partner, Neptune, Pluto's closest planetary neighbor in space. Though their orbits cross, they never collide. Why? Because of a strange orbital resonance. For every 3 orbits Neptune makes, Pluto completes exactly 2. This 3-to-2 resonance locks them in a celestial rhythm, ensuring they stay at least 17 astronomical units apart. That's over 2.5 billion kilometers. Isn't that astonishing? That resonance, it wasn't random, but the result of a dynamic dance, preserved over billions of years. Perhaps dating back to the chaotic birth of our solar system, where massive bodies silently adjusted each other's paths. Once, scientists believed Pluto was the reason behind Neptune's orbital irregularities. But when Pluto's true size was revealed, that theory faded. Instead, a new truth emerged. Pluto isn't a ruler of orbits, but a humble wanderer in the Kuiper Belt, shaped and shifted by forces far greater than itself. After tracing Pluto's mysterious connections with surrounding bodies, we now arrive at the most heartbreaking chapter in its tale, the moment it was stripped of its planetary title. On August 24, 2006, during a meeting of the International Astronomical Union, IAU, in Prague, a new, stricter definition of planet was approved, with 3 specific criteria. First, it must orbit the Sun. Second, it must have enough mass to reach hydrostatic equilibrium. And third, it must clear its orbit of other celestial objects. Pluto met the first 2, but stumbled at the third. For it resides in the Kuiper Belt, a crowded neighborhood filled with icy bodies like Eris, Haumea, and Makemake, and Pluto just wasn't big enough to sweep them aside. The discovery of Eris in 2005, thought to be larger than Pluto, raised a dilemma. If Pluto's a planet, shouldn't Eris be one too? To preserve the definition of planet, the IAU created the dwarf planet category, reclassifying Pluto alongside Eris, Ceres, Haumea, and Makemake. This sparked intense backlash. Alan Stern of New Horizons argued that clearing the orbit rule was flawed. Even Earth hasn't done that completely. The public felt the loss too. To them, Pluto was more than science. It was a cherished symbol from childhood. What do you think? Should Pluto reclaim its planetary title? Though demoted, Pluto hasn't lost its allure. In fact, it became the center of a profound debate, scientific and philosophical, about how we define a planet. Then came 2015, when NASA's New Horizons spacecraft revealed something astonishing. Beneath Pluto's frozen shell may lie a hidden ocean. Images from the Sputnik Planitia region showed cracks and bulges, signs that pressure from a liquid layer deep below might be pushing upward. Geophysical models supported this theory, suggesting the subsurface ocean could contain water mixed with ammonia or salts, allowing it to remain liquid at chilling temperatures near -200 degrees Celsius. Could it be that this outcast world, once stripped of its planetary title, is quietly hiding a secret ocean, a place where life might still whisper in the dark? If Pluto's quiet yet extraordinary journey sparked your curiosity, leave a like, share this story, drop your thoughts in the comments, and subscribe to our channel for more cosmic mysteries waiting to be uncovered at the edge of the universe. That hidden ocean may reach depths of 100 to 150 kilometers, buried beneath an icy shell 200 to 300 kilometers thick. A veil thick enough to hide secrets for eons. Its warmth, faint but persistent, is thought to come from the radioactive decay of uranium, thorium, and potassium within Pluto's rocky core. A quiet fire, just enough to keep the water from freezing solid. Some scientists believe that, in the distant past, this ocean may have touched the surface, its presence revealed through violent impacts that cracked the icy crust, leaving behind haunting scars like those seen in the eastern Tombaugh Regio. This revelation changed everything. Pluto, once thought to be a frozen corpse drifting through the void, now emerges as a dynamic world, whispering tales of internal motion and hidden heat. But if an ocean truly stirs beneath that ice, could it harbor life? Some fragile form, breathing quietly in the silence? No direct evidence has been found. Yet that question still lingers, carried gently by the cold winds of the cosmos. Though no signs of life have yet emerged, the presence of liquid water, so vital to life as we know it, along with organic compounds like methane, nitrogen, and carbon monoxide, has made scientists pause and wonder, could something be alive out there? If so, it might be no more than simple microbes, like the ones that thrive near hydrothermal vents deep beneath Earth's oceans, in places where the sun has never reached. Their energy could come from silent chemical reactions between water and minerals in the rocky core. Serpentinization, releasing warmth and hydrogen. Some theories even suggest that under immense pressure, methane or chloride gas pockets might form, offering the bare essentials for primitive life. It remains a hypothesis, yet one compelling enough to spark pursuit, making Pluto not just a frozen relic, but perhaps the universe's quiet invitation to seek deeper. Pluto's recent discoveries point to bold new frontiers. Though New Horizons only flew by briefly in 2015, it revealed immense potential. Scientists now envision landing missions or probes that drill through its icy shell to reach the subsurface ocean. Advanced tools like infrared spectrometers, cold-resistant robots, and remote chemical analyzers could uncover signs of life and inner geological processes. Another idea is to send an orbiter, allowing continuous, detailed study of Pluto's atmosphere, surface, and moons. Future missions may target not just Pluto, but the broader Kuiper Belt, unlocking clues about the solar system's origin and the birth of icy worlds. Yet, the challenges remain daunting. Vast distances, decades-long travel, high costs, and the need for ultra-durable technology in a harsh environment. Still, Pluto's scientific potential, from hidden oceans to possible life, makes it a target we can't ignore. Its journey from the 9th celebrated planet to a debated dwarf reflects humanity's ever-evolving understanding of the cosmos. From its discovery in 1930 to its demotion in 2006, Pluto's journey isn't just science. It's a reflection of our struggle to define our place in the cosmos. Small, yet it holds a frozen heart, an underground ocean, and perhaps the spark of life. A distant world that whispers to our deepest questions. And one day, as technology returns us to that frozen frontier, it might reveal answers beyond imagination. Pluto reminds us that in a universe so vast, the tiniest worlds may hold the greatest secrets. What do you think? Could Pluto unlock the next big mystery? If this story moved you, tap the like button, share it, drop us a comment with your thoughts, and don't forget to subscribe for more journeys beyond the stars. If you want to continue discovering untold mysteries, don't forget to subscribe and ring the bell, because the next video might change the way you see the universe.